It's called a neutralisation reaction. Okay, neutralisation reaction. And so we've been looking at, over this term, elements and atoms. We've looked at the power of atoms, nuclear power. We've discussed some of the ethical issues related to nuclear power. We've understood a little bit about radioactivity and alpha, beta, gamma particles. We've moved from that to looking at chemical equations. And we've started to see that there's a range of properties of chemicals. So we talk about acids with pH values that are really low, between, say, 0 to 6. We looked at neutral. Neutral means it has a pH of 7. And then alkali or bases. Those two terms are sort of interchangeable. And they have pH values of 8 to about 14. And so what happens if you get an acid like hydrochloric acid and mix it with an alkali such as sodium hydroxide? All the hydroxides, by the way, are alkali. All the acids, of course, are acidic. What happens if you mix them together? Well, you should, if you've got the right quantities and the right strengths, be able to get back to neutralized. It should absolutely be a pH of 7, right in the middle. And if you had universal indicator, acid would turn universal indicator into a red color, and acid would turn, alkali would turn a universal indicator into a bluey purple color. But if it's neutral, that universal indicator would be green. And so you've already seen last week the range of colors of universal indicator. We started to look at some other indicators like litmus paper. If you put blue litmus paper into an acid, it turns red. If you put red litmus paper into alkali, it turns blue. If you put blue litmus paper into alkali, it doesn't change. It's obviously going to stay blue. And similarly, we saw that there were some other ways of indicators, including red cabbage. And it's actually something you could do at home. Boil up some red cabbage, filter it out, strain it out, and use that liquid as an indicator of whether something is an acid or a base. So acid have low pH numbers, bases have high pH numbers. So here's some examples on the screen that I'm sharing. You can see 3 examples here. One is sulfuric acid. Now, we tend to only use sulfuric acid in a science laboratory because it is strong. If you added potassium hydroxide to that, remember all the hydroxides are bases or alkali, then you end up with a salt. And in this case, it's potassium sulfate plus water. Now, at this point, you're probably going, hang on, salt. I always thought salt was sodium chloride. Well, that's true. So sodium chloride is our common salt. It's the one that we put on our chips. It's the one that we buy in supermarkets and so on. But there are other salts. And today we're actually going to have a look at different chemical salts. And we're also going to have a look at some of the more common ones you can buy in shops, like pink salt and a few others. So there's a little bit of a video at the end for you to have a look at for that. But before we do, let me just take you through these 3 examples. I'm taking you through the first one. So sulfuric acid plus potassium hydroxide produces potassium sulfate plus water. Now notice again the arrow means there's a chemical reaction occurring. And you'll probably notice that the potassium has swapped. Potassium hydroxide was involved with the hydroxide. It's broken up, and then the potassium joins with the sulfate and becomes potassium sulfate. And potassium sulfate is a salt. It's not one that we'd put on the chips. The second example there is nitric acid. Again, nitric acid is a strong acid that we probably wouldn't use except in a science laboratory. So nitric acid plus lithium hydroxide produces lithium nitrate. And notice again that there's a swapping. So the nitrate goes from the acid and joins with the lithium to produce a salt. So lithium nitrate is a salt plus water. Now you know that if you add salt in water, it dissolves. So this sort of reaction, you wouldn't actually see anything occurring because it's all clear. But the only way to test that something's happened is put universal indicator into nitric acid, it turns red. Put universal indicator into lithium hydroxide, it turns bluey purple. When you put the two together, the solution turns green, which is neutral with a pH of 7. And the last example there, and I'm just entering a few more people into class who are coming in. The last example there is sulfuric acid plus lithium hydroxide. So if you use those two, mix them together, there's a reaction and it produces lithium sulfate plus water. And lithium sulfate is another salt. So this morning, two things to understand. One is an acid plus an alkali produces salt plus water. And the second thing is that sodium chloride is not the only salt. There are lots of different salts, and they usually have a metal like potassium or sodium or lithium and something else joined to it. So in the case of common salt, it's sodium chloride. But you can see the examples here: potassium sulfate, lithium nitrate, and lithium sulfate.